Hello, hello, hello. Is everybody deep in a food coma? Yes.
Very good.
All right, do me a personal favor, don't fall asleep, because this is going to be really interesting. Two of our esteemed conference participants had the great idea of reaching out to us with things that they thought everybody should hear about, which is such a good idea. If you want everybody to hear something, tell it to the people with the microphones.
First is, Anke wanted to re-emphasize, so the Lightning Talks submission is open until tomorrow morning. And you can reach out to her best via Slack at Anke, or just talk to her when she's around. And then
Lukas reached out to me to remind me that there is an ongoing wallpaper, login wallpaper. Is it a competition? Is it competition? It's a voting, definitely. To remind all of you to check it out and see, because we're all looking at that login screen. Might as well be a good picture, right? Yeah.
Cool. And now we're thrilled to announce a long friend who I got to know him many years ago when he helped with the NEOS Awards as a jury member. Later on,
Oh, I didn't know that.
Oh, he did. And later on, he became speaker, not only speaker. He, back then, won the Best Speaker Award. And he is, and this is something actually we would want to show you a little more. He's a speaker from an external community. He is in the Contao core team. And we always seek to get speakers not only from our community, but also from other places, from external, like also to get an external point of view. And now we are very happy to have him here. And just to mention the shop where you bought your tickets, that's also we just wanted to recommend that to you. It's Pretix. Back then we started with Eventbrite, but they charge a lot, and now we switched to an open source solution. So they are from Germany, Heidelberg. Whenever you are looking for a similar thing, we can just strongly recommend it. And now, without further ado, please welcome Yanick on stage.
Thank you.
Happy to have you.
Don't forget to post your questions in the app.
Cool. Wow. Thank you. It's good to be back after 4 years. It was back in Dresden, yeah, when I joined the NEOS community for the first time. And back then, I gave a talk about composer internals. I don't know if a few of you might remember. It was a lot of math and a lot of algorithms and a lot of complex stuff, and it was really interesting. And so you might know that whenever I give a talk, I like to bring a story along. And today's story starts in, 2022. It's full circle. I happen to work for a customer in the tourism sector. And there was a new requirement. And you've all seen this requirement. I will show you a little mock-up because this will feel very, or look very familiar to you. It's in German because that customer is a Swiss customer. So it was about point of interests. Like you've all been there. You've all hopefully booked some vacation maybe, or you've looked for a hotel or a restaurant, or these typical lists where you have a lot of objects, and then you want to filter on the left or right side or wherever for categories, or you have these typical price range sliders and stuff. And then there's this tiny little, search box on top. And then you have to ask your customer, what do you expect of this box to do, right? You've all been there. And, there's a rather famous touristic place in the Bernese Oberland, which is called Grindelwald. And there is a problem if you listen to the word Grindelwald, because English native speakers, they usually write EL with LE, because handle, bundle, candle, you know the deal. And so that was a simple requirement that they expect simple, letter scrambles to work. So typo tolerance was a hard requirement. But at the same time, we were talking about, Switzerland is not so big. I don't know if you've visited before or you are living in Switzerland, then you know that it's a small country. There's not so many hotels or places to visit. So we were talking about smaller lists, maybe a maximum of 10,000 point of interests. And then I sat there. You probably know this situation, right? Yes, this is obviously AI generated, and obviously none of the logos is correct. I left this in deliberately just to show you that AI is AI. It's not really intelligent sometimes. But I sat there and I knew, okay, good, typo tolerance, what are we going to do? Do we pick Elasticsearch? Are we going to host it ourselves? Do we pick a hosted solution? Should we go for Algolia, OpenSearch, TypeSense, SmileySearch, the deal? And this time I thought, well, it's just not, I just have 10,000 objects. I don't need like all the power of Elasticsearch. There must be a solution that just makes this easier for me. And by chance, at that time, in a very different project, I worked with SQLite. And SQLite is everywhere. SQLite is in your phones like 1,000 times. It's in your car. Probably it's in your fridge. It's argued that it might be the most deployed software, most commonly deployed software in all the world. Close contender to Loupe or so it's basically everywhere. And SQLite has a super powerful function, feature, which is called create function. So it allows you to register your own custom functions that you can then use in your queries. And the obvious choice for these simple typo-tolerant implementations is Levenstein. This is Mr. Levenstein, if you've never seen a picture of him before. And I knew that whatever I'm going to do, I'm going to tinker with this thing. I want to build something. And whenever I'm going to encounter a problem that I cannot solve with native features, I will always be able to resort to custom functions. And so that's just to show you that this works without a problem. So we're going to instantiate a new PDO in-memory SQLite instance. Then there's some stupid Loupe Levenstein function that does nothing else than just the native Levenstein distance calculation between two strings. And then you basically insert the correct word. In that case, that's Grindelwald. And then you can register this or create this function and make this known to SQLite, and then you can use that function, and then you can essentially have your Grindelwald, which I'm going to call it now, so the mistyped, and you will get the result. So the ID is 1, and it has a number of typos or Levenstein distance of 2. So I knew that whatever I'm going to do, I will be able to sort of create something that might be useful. So I set out to do that. So there were a few requirements, and one of the requirements was obviously platform related. So my goal was I don't want to, every single time, if I have to have this discussion, talk about, we have to sort out this container, and we have to decide whether to use Elasticsearch, and I have no idea how much RAM I'm going to use or need or not for these simple type of lists. But at the same time, I also didn't feel like reinventing the wheel and implementing an entire database in PHP. I don't think this would be a smart idea, but if you want to do that, feel free to give it a try. Anyway, so PHP and SQLite only, which makes it possible to also run this software that I'm going to talk about in a minute, basically on a stupid shared hosting solution, if you want to. And then I had some DX requirements, because who has worked with Elasticsearch before and was just overwhelmed with all the features that you can configure? I think, there's quite a few hands. And who has worked with SmileySearch maybe before? It's an alternative, an alternative depends on your use case, but I think MileySearch does a very good job at making very basic search simple. And I wanted to copy that. And if you've worked with MileySearch before, you will notice that it's very much inspired by MileySearch. And then there were some functional requirements, like obviously I need to filter. You've seen the mock-up before. I need to be able to filter by categories and price and geodistance, and then obviously sort by relevance and all of that, and typo tolerance. So I started working on Loupe. Loupe is French, and it just means magnifier. And I started, it's already, it's a long time ago already. It's more than 3 years, and back then it was not usable, but now I think it is. So every search engine usually works with what we call documents. So for reference, we just have an ID. Every document has an identifier, and then there's some this is a made-up example. There's no Panoramastube in Grindelwald, I guess, I don't know. But there's a name and a teaser, and then there's some categories, which is an array of strings, and so on, and then average price, which is this typical, the dollar signs 1, 2, or 3, which obviously in Switzerland is always 3. Then coordinates, latitude, longitude, whatever, you get the point. So when it comes to developer experience, then it's really very simple. You just say which attributes you want to have to search or should be searchable, which ones should be filterable, which ones should be sortable, and then there's a whole bunch of other stuff you can configure, but you absolutely don't have to, and that's basically it. And then for the search, the query, the opposite basically, or how you would search it is, well, you pass in the query, that is your user typing, right? Then you have your filter, which is SQL language inspired, and some sorting, and that's basically it. So let's check the foundation of a simple SQLite database, how you would structure that. So obviously we need a documents table where we just take our JSON, our document, and we just bang it in there. We have an internal ID because of performance reasons, and an external, which I called user ID. But at the end of the day, that's just a document. And then there's some internal stuff like, engine version, so that I know when to re-index if things change. And then there's also the document schema, because I was like, I don't want to, on every single time I need a simple search, I didn't want to go at a project and say, well, teaser is a string and categories is an array of string. No, Loupe just takes the first document, that's going to define the schema. So you do basically composer require, you bang in your documents, and you're good. That's the idea. So filtering is what I started out with, because filtering is very easy that's where relational databases really shine. So that's basically we have single value attributes that you saw before, like the stars or the average price, and then that's what I called multi-value attributes, which is just categories. It's an array of strings, right? And so the single value attributes are like the easiest thing you can think of. You just add another table column next to your documents table, and basically, well, filtering for all the documents that match that filter is super simple. And multi-value attributes work similarly. You just have to index the values individually, and then you build a relational table. And then that's basically it. It's a bit more complicated if you want to exclude, but at the end of the day, it was written rather quickly. And the query is not, you can do it with joins, you can do subqueries, doesn't really matter, but at the end of the day, it's all the documents where the attribute, in that case, categories matches, and then the string value is fondue, which, by the way, in Switzerland always means cheese fondue, because fondue is French and means molten, and I don't know when meat fondue became molten. That's really weird. But anyway. Then there's the combination. Obviously, if you combine multiple filters, then you get like a filter queries like this. So you need to write a parser to understand what is an attribute, what's an operator, what is the value, grouping with brackets. At the end of the day, it's a bit more work. You write your lexer and parser, but there's cool libraries you can reuse. Doctrine lexer, if you ever need to write a parser, have a look at that library. It makes it really easy to write your own lexer or parser, or both of them. And then, turns out it will give you a longer query, but you can just forward that to SQLite, and SQLite Query Planner will optimize that, and it's really, really fast. So good, that's done. So filtering was really easy to implement. There was one thing, geodistance, because SQLite natively does not have geodistance functions yet. There are plugins, but the idea was to have something that is natively available basically everywhere. So, well, the coordinates, you just store them again alongside your document. And then, we can register our own function, use any of the Composer, 100 libraries that do geodistance calculations, and basically you then compare the distance to a given coordinate pair in the database, and you check whether that's in the range of 10,000 meters in that case. And but there was a performance issue, so it worked in my tests, obviously, but because the library was tested and works well. But you can see, by the way, that's the radius of 10 kilometers, so you can really see how small Switzerland is. But obviously, this is where Grindelwald is, and there's a lot of places outside of this radius, and it was slow because, well, my custom function had to compare the distance for every single one of them. So what's the obvious choice you can do? Well, you can calculate bounding boxes, so southwest, southeast, northeast, and northwest. That will give you 4 coordinate pairs. And then you can pre-filter kind of all the documents that are in that square, and you then only apply the geodistance stuff for what is in that square. And that was fast enough for me. OK, on to the final boss, the typo-tolerance. So in PHP, the problem is, or if you've worked with language stuff before, you've probably noticed that Python is the best language to do that. Now, in the AI world, probably you've had some, you've worked and trained your own models and stuff. So you might have come across that fact. But in PHP, unfortunately, we don't have those tools. So but what we have is an extension called INTL, or internationalization. Probably you've seen that before. It's basically, I guess in the CMS world, it's basically you always have to use that. Otherwise, working with multiple languages becomes a bit difficult. And there's a cool component in that extension, which is bundled in PHP Core. And it's called break iterator. And you can basically break a sentence or also an entire document into sentences or words according to rules. So in that case, according to German rules, because, well, we all know like exclamation mark and question mark defines a sentence. But in Spanish, it's the upside down question mark and so on. So there are different rules. But at the end of the day, you can iterate over that, and it will give you an array of words in that case. So we can use that. Then we do some normalization stuff, like, you can't see here, that's an old screenshot, but basically transforming special letters like umlauts in A, E, and so on, normalization. But you just put those into a terms table or tokens or whatever you want to name it. And then there's basically also a table, a relational table, and we do the same thing. We store in what attribute it was found, and also the position. That's only relevant for phrase search, and we'll get to that in a second. So what do we have to do? Well, we have to fetch all the documents where the distance to Grindelwald, so our user query, is smaller than or equal to 2 if you want to tolerate 2 typos, right? Well, the problem is that becomes really slow because, again, that will be done against every single term that you have in your database. And, if you compare it to, that's Kandersteg, that's another famous place in Bernese Oberland if you ever want to visit. And the Levenstein distance is 9. And it's just so it's not even remotely close, right? And I don't care if it's 2 If it's 9 or 15 or 50, it's just not relevant for the search. What I want to know is it equal than or less to 2? And basically what we need is we need a way, like before in the geo example, we need a way to restrict our thousands and hundred thousands of terms to a manageable set where we can then do this Loupe Levenstein. So this special function is not the problem, but we need to reduce our set very quickly. So it did work, but I basically had to wait 1 minute for a search result, and I figured it's probably not what you would expect from a search engine to wait a minute for correct results. So there are some obvious quick wins. What can we do? Well, we can store the length of the term, for example. You could also add the length to the query, but that way it doesn't even have to calculate it for every term. And if you want to tolerate 2 typos, then, well, the word has to be at least 9 or not longer than 13 characters long in order to match our Grindelwald, right? So that's an obvious improvement that we can already do. And then there's stuff that you could do, like the first letter that must match. It would reduce the set a bit. And yeah, I thought there must be a solution. I don't want this. I want to tolerate a typo at the beginning of the word. You know, there's this little child that wants to build this house with the Legos, and it has to work. And even if I added this filter for all the words starting with the letter G, then I would still have 10 seconds to wait for a search result, so that was not a solution anyway. So what do the big players do? How do other search engines solve typo tolerance? Well, there's a whole bunch of algorithms that you can look into, from n-gram index to, you know, finite state transducers. Yeah, that's already a mouthful. It all turns out to use a lot of RAM. So not all of those algorithms, but most of them. That's probably also the reason why most of the search engines require a lot of RAM, because they can keep a lot of stuff in RAM, in memory, and then answer your typo-tolerant queries very quickly. But that was not a solution for me, because then I might as well just use one of the existing solutions, right? And so I Googled a bit, and one day I stumbled over this paper, academic paper, that's called Efficient Similarity Search in Very Large String Sets, and that sounded very intriguing. It's German Hasso-Plattner Institute and Humboldt Uni, so probably also some bigger names in Germany. And this is a paper published in 2012, and I read this paper 1,000 times, and I didn't get it 999 times. And at some point, I sorted it, and I started to implement this algorithm that is described in this paper in a standalone library. You can use it. By now, it's been extended. There was a bug in the paper that I fixed. There's more stuff that this library can do on top of what this paper actually outlines. So if you want to have a look, then you can. And unfortunately, a version of this talk I prepared would have included explaining the entire algorithm, but we would still be here in an hour probably, because as I said, after reading it 1,000 times, I still didn't get it. And so I decided not to explain you all the details of the algorithm, but I will try to tell you the essence of that algorithm, what makes it so clever. And what makes it clever is that the idea is that it doesn't replace Levenstein. And the idea is exactly what we need. Reduce all the candidates to a manageable size first. That means we tolerate false positives in order to do that. And are there any computer science students, even if it's 20 years ago? You sound familiar. So if you've ever stumbled across a Bloom filter, it's the same idea. It's not a Bloom filter, but it's the same idea, like tolerating false positives in order to quickly reduce all the candidates to a manageable size or set. And the cleverness here is, well, we are talking about typos. So what are the ways to make typos? Well, basically all the letters on your keyboard, or even more, right? Emojis and stuff. Basically, all the letters of your alphabet, which in computer science is Unicode. And the cleverness of this algorithm is, well, what if we just said, our alphabet now consists only of 4 letters. So not 26 or even more, not 1,000, just 4 letters. If there are only 4 letters in our alphabet, then there are not as many possibilities to make typos, right? So the Levenstein operations, there are 4 Levenstein operations. Match, replace, insert, and delete. Basically, either you picked the right letter, it was a match, or it was the wrong letter, which means it could have been any of the other 3, because our alphabet only has 4 letters. Then you could have added 1 letter too many. Or you could have omitted one which you should have put in. That's the worst case, because then it can be any of the letters, and that's, in that case, just 4. So you don't have to get all of this. It just means that for every letter that you type, there is only a maximum of 9 possible paths. So basically, either you hit the right letter or 8 wrong ways. So it's a really reduced set of possible outcomes to make a typo at any letter, right, of your word. Now, how do you reduce that, or how do you get to a letter of 4? Well, our alphabet in computer science is Unicode, and the formula is pretty straightforward. You take the Unicode code point, and you do that modulo 4 and +1, just so that you don't end up having a 0. But basically, the small lowercase h is normally the 104th letter of our alphabet, and that just becomes our first one now. And the lowercase a would be position 97, so it becomes the second letter. And this lowercase d now also maps to our first. So it's effectively lowercase h and lowercase d are the same letters. Obviously, if we combine a huge alphabet to just 4, then there are going to be collisions. Hence, there are going to be false positives. But what you can do with this algorithm is you take a word, when you index it, you calculate, so for Grindelwald, you calculate all the state with G, R, E, and so on, and you end up with a number, which is called state. And you can just put that in your database alongside, the length that we've discussed before. And so Grindelwald now has a state of 5 million whatnot, and all the other ones, obviously, the shorter the term, the lower the state. And you get a number. And now, on the query side, when you query, you take the query from your user, so in that case, it's the typo, the Grindelwald, and you start checking. Either you take the entire, or there's another smart optimization. If we are tolerating false positives anyway, you can also just take, for example, only the first 7 letters, because that will be calculated faster, and we tolerate false positives anyway. And you calculate, okay, what are the possible states for those 4 Levenstein operations, which we've seen at every single letter, there can only be 9 possibilities. And that can happen really fast. It's just CPU-bound work. It happens really, really fast. And then in that case, we end up having 2 states. So one is probably a random false positive, and the other one is our Grindelwald, right? And that is super fast. So what you then end up doing in your query is, well, we apply our basic optimization. So it still has to be all the terms between 9 and 13. Then the state has to be one of what we've calculated with the algorithm. That I recommend you read the paper if you want to dive into that and maybe hurt yourself along the way like I did. And then only on this very reduced set, which just to recall, it contains false positives because of the collisions of the letters. And then we filter with our function that we wrote ourselves, right? Which in our example is very simple. It's just the Levenshtein algorithm. And this makes searching typo-tolerant really, really fast. So what does that mean? So performance-wise, Loupe, I allowed to not only copy the DX or from MileySearch, but also the test files. It's open source, so I'm allowed to. There's a movies JSON contains 32,000 movies with title and teaser. That ends up being about 75,000 terms, so that we would have had to compare with our in-memory Loupe Levenshtein function. And the database gets to about 230 megabytes. There's a lot of stuff you can do to optimize that, but disk space is basically pretty cheap, so it doesn't really matter. And if you want to search for Anakin Skywalker, just to show that it works with a typo on the beginning of the last name, including relevance calculation, which is also done with a custom function, and facets, so statistics about the search result, happens in about 30 milliseconds and uses about 10 megabytes of RAM. And thanks to AI and stuff that we can, it's really complex to write those queries. And I did it all by myself before using AI, but now AI can help with query optimization a bit. So we have been working hard, actually yesterday when I sat in a train, to maybe push that below 20 milliseconds. And that was, well, more than I actually expected. So I was really happy with that. When I set out to write this, I said, well, anything below half a second is probably good enough for my use case, but now it's really fast. And you can build cool stuff. As I was introduced, I'm a part of Contao core team, and we've implemented that in the backend search. And so you can basically type Conato instead of Contao, which is done very often by our customers. And you can build stuff like this, which is really cool. That's a query how it could look like. That actually gets forwarded to SQLite. In the meantime, it's become a bit more complex even than that. But the good stuff is you don't have to write it because it's all there. Loupe can do a lot more. It's not just Levenshtein. It's actually Damrau Levenshtein or Damrau. I have no clue how to pronounce that. So this example is actually just one typo and not two, because it's just a transposition. So it counts as one error and not two, because human beings tend to, swap letters very often. It can do highlighting, phrase search. So if you put it in quotation marks and search for Neos conference, then it will find. That's why we store the position in the attribute. It will find that. You can do excluding queries. It does stemming. So basically, cats and cat is the same. So it's like the word stem. That's one of the algorithms that you can use. Or Loupe uses out of the box. You don't have to do anything. It uses n-grams for tokenization, which is another talk all by itself. Relevance calculation based on a number of factors, distance, exactness, and so on. And as I said, facets that you've seen on the screenshot before on the left side, like which categories does this search, this match belong to, for example. And that's really cool. And then the future, it's still a 0.13, I think. And I want to work towards first version, first stable version. I mean, it's stable. It's been used in production on many systems, but I just didn't tag it yet. Loupe is a prefix search, like many other search engines, which is a bit of a problem, especially in German, but also in English, because if you search, for example, for brush, it won't find toothbrush. So you have to split tooth or toothbrush into tooth and brush, because it's a compound word. And as you know, in German, we have basically German consists only of those words. And decomposition is really, really hard, especially in German. I've started working on that, but you know this very famous example, which really exists. And the problem is in PHP, there's no such thing. As I've said, it's all there in Python, but in PHP, we have to start from scratch. And I started working on that, so I'm sure that this year I will be able to finish this work, so we can also support searching for suffixes if they are standalone words. So I will provide you with a few links if you want to. It's basically all open source. You can just install it and use it. It's on Loupe-PHP because Loupe was occupied /Loupe. And then if you want to build it, I suggest, or if you want to build your own search engine, I suggest checking out the Content Management System Interoperability Group /search. That's called SEAL. It's also another project, SEAL, Search Engine Abstraction Layer, the same as Doctrine DBAL. The same idea, basically, you can tie your app, you could tie Neos to the search engine abstraction layer. And then you can configure any of the supported adapters, one of them being Loupe, which means everybody can start out using Loupe locally. You can just run it everywhere. You don't have to worry about, you know, privacy or whatever. You can get up very quickly, and then you can change later on if you need, for example, AI integration with embeddings and stuff, and you can switch to Milosearch or Elasticsearch, and there's a whole bunch of adapters that you can use. And if that helped you, then of course you are also very welcome to sponsor my work. Yeah, those are my contact details. If you want me to help you integrate search in your apps, then feel free to get in touch. And other than that, have fun searching.
Thank you so much, Yanick. There's only one host. I lost the other host to Vital Neos Award Prep. But I promised that I would be able to do this. You're going to need to help me because I need free hands for all of the questions.
Oh, so many. Okay,
3.
Thank you so much. Wow.
3.
3, okay.
First question. Is the SQLite function, once registered with SQLite create function, executed in SQLite like stored functions in other RDBMS, or is it executed in PHP?
It's, I guess it's a bit of a ping pong between PHP and, but it's SQLite it runs embedded, so I wouldn't exactly know how much ping pong there happens. But we will have to check together. So whoever asked that question...
Florian did. Florian did. It's one of the very few questions that aren't anonymous.
OK, good. So we'll check that after the talk.
OK, so next question. When you use just the first part of the search term and calculate the index state and use it for the query, is it then not different from the state of the whole search term? So...
Well... Yes, it would be, but you have to, the length that you define, you have to configure it once. So if you configure the length of 7, let's say, it has to be done on the indexing side, obviously, as well as on the query side. So it's basically as if the word were only 7 letters long. But yes, of course, they have to match, otherwise the state will be different. Very smart remark, yes.
We have a very smart audience.
Yeah, I can tell.
Last question. That starts with another question, so this might be a repeat offender.
Okay.
As you have a table with all term words, couldn't you also offer an endpoint for autocompletion as you have all single possible words?
Yeah, technically you could. But again, if you want to support typo-tolerance, I don't know how easy that would be to do. But in theory, yeah. So we could try. So it's an open source project. Try and contribute. That would be fun. Yeah.
Throw the challenge right back.
Yeah. Yeah.
All right. I don't think any more questions came in. Thank you so much. Huge round of applause.
Thank you. Also for the present.
And as usual, don't forget to rate the talk. Thank you so much. And we will see you here in about 15 minutes again. Thank you.